Rotational symmetry and rotations.
What did the little girl do when her puppy chewed up her dictionary? She took the words right out of his mouth.
Today's lesson is on rotational symmetry and rotations. The Indiana Academic Standard is 7.4.2. A rotation is a transformation that turns a figure about a fixed point called the center of rotation. A figure has rotational symmetry if it can be rotated 180 degrees or less and match the original figure. When a figure has this property, the angle of rotation is the smallest angle measure the figure must rotate to match the original figure. Example number 1, identifying rotational symmetry. As shown, do the letters H and N have rotational symmetry? Can we take an H and turn it and have it match up? Yes, we can. We could take the H and we can literally turn our paper upside down and it still looks like an H. So an H has rotational symmetry. We can do the same for an N. Here you can see the N still looks like an N. If I turn it back the other way, we still have an N. So both letters look the same when rotated 180 degrees. So they have rotational symmetry. Quick check number 1. Does the figure have rotational symmetry? Look at the first star. Could we turn the paper and have the same star? Try turning your paper and see. Yes, we can. It does have rotational symmetry. Let's take a look at the second star, B. Try turning your paper. Does it match up exactly? It doesn't. So this one is no. How about the last one? Try turning your paper and see if it matches up. If you're not sure, we can even take a little tiny scrap paper. We can roughly draw the shape. Can I turn it and does it look the same? If I turn it upside down, it does look the same. So this shape also has rotational symmetry. Literally, the best way to tell is to either redraw it and turn it, or just turn the paper and see if it looks the same. I am not going to require you to find the angle of rotation, so we're not going to do this. For the next example, we're going to rotate a figure. We're going to graph triangle ABC with the vertices 0, 0, 3, 1, and 2, 5. Now we need to rotate this triangle 90 degrees about point A. So what we're going to do is we're going to turn our paper 90 degrees. So if we turn our paper 90 degrees, we're still going to graph those same points. We're still going to graph A prime at 0, 0. B is at 3, 1, so there's our B prime. C is at 2, 5. So we still use the same coordinates. We've just turned our paper 90 degrees. So now we have our two triangles graphed. We can turn our paper back the correct way and give the actual coordinates of A prime, B prime, and C prime. A prime is still at 0, 0. B prime is now at -1, +3. And C prime is at -5, +2. another example like this together. We'll also do several in class together so that you get an idea of how to do rotations. The biggest thing with rotations is understanding that if you turn a shape, you don't change the area. It's still the same shape. We're not going to find the angle of rotation on this flower, but I'm going to ask you, can we rotate this flower? Does it have rotational symmetry? Try turning your paper and see. If you have the same shape every time you turn it a little bit, then it does have angle rotation or rotational symmetry. So this would be yes. For number 3, we have to graph the triangle TRG with vertices at 0, 0, 3, 3, and 5, 1. So we have triangle TRG. And it's best to use a straight edge to connect your lines. Now we're going to rotate it 180 degrees about point T. So if I'm going to rotate it 180 degrees, I have to turn my paper completely upside down. And I'm going to graph all those same points. This time I'm going to use a different color so that you can see it. Okay, T was at 0, 0, so it's still right there. And I'm going to put my T prime right here. R was at 3, 3. And G was at 5, 1. And again, use a straight edge to connect those dots. So we've rotated it 180 degrees. Now you can turn your paper back upright. And we're going to write the coordinates of the new triangle. So T prime is still at 0, 0. R is at negative 3, negative 3. R prime, that is. And G prime is at negative 5, negative 1. We'll do more examples together in class tomorrow. Have a good evening.